Hello and good evening, everyone. I hope today we have all the three sections joining for the live class. Okay, you are to put down your attendance in the chat box with your name, your class, and your section clearly. So in the last class there was some problem with the connection, so that's why we could not actually continue with the class. But the same evening I had uploaded the video of the introduction, the introductory class for friction. So all those who haven't seen it, you can go on to the same channel and just go through the video. It is self-explanatory. It is very simple. I have used absolutely simple language to make the introduction and the initial concept of friction very, very clear to you. But for the sake of rest of the students, if you have not gone and seen the video, let me just revise the same class again. Quickly we'll go over the class and we will move on to the topic which is ahead of friction. So what is basically friction? Friction, in the previous chapter also we have learned that whenever there is any object which is moving and the object is in contact with another object. So for example, this ball is going to move and the ball is continuously in contact with the ground below. So the ground will offer an opposite force to the ball. So the ground is going to offer an opposite force like this. This opposite force is actually a resistance to the ball. Resistance means in Hindi we say rukavat. Ek tarah ki rukavat means a kind of an opposite force, right? So this opposite force is called as friction force, right? So if the motion is in this direction, if the motion is towards your right, then the frictional force will be towards the left. So every time, as long as the ball is in contact with the ground is going to provide a frictional force which will try to stop the ball. So what is friction? Friction is a force which will always try to slow down the ball or slow down any object. Okay, or we can say it is a kind of a resistance. It is a kind of an enemy to the motion of any object. So this also we discussed, why a person is comfortably, he is able to walk on the road, and why the other boy, he slips quickly on a banana cover. That is because the cover is very smooth, and when the cover is smooth, it makes the movement of the boy very fast. So there is something which is happening which is making the boy fall. So we will come to this slide again. I'll explain to you why he falls. Okay, understand friction with the help of this boy swinging on a slide. So he's actually swinging. So how does the friction apply in case of this scenario? When the boy is swinging, so first time what happens is the swing comes in the forward direction and then it goes back and then comes in the forward direction and again goes back. So the swing takes a to and fro motion. To and fro means forward, backward, right? So whenever the swing is coming in the forward direction, something like this. So this is the motion of the swing. So now there is air around this boy, right? So that air will try and give an opposite force to the body of the boy. So that opposite force is called as friction. So whenever the swing is coming in the forward direction, there is going to be a friction which is called as air friction in the backward direction. Now then the swing goes back. Okay, now whenever the swing goes back, the motion of the swing is in this direction, the backward direction. So what will happen? The air is going to actually push the swing in the forward direction. So this is going to be air friction. So every time the swing goes forward and backward, there is always an air friction which is acting. So in this case, it is air friction which is acting in the opposite direction to the direction of the motion of the swing, right? So that's why even if you don't push the swing, after some time on its own, slowly the swing is going to reduce the speed and come to a halt. It's going to come to rest. Why does it come to rest? Because every time it goes forward, there is an opposite force acting. Every time it goes backward, there is again an opposite a force acting. What is this opposite force? It is friction. So when we were talking in terms of the ball and the ground, it was ground friction. Now here it is air friction, correct? So there is friction which stops the ball. So again, this we have studied, the ball moving on the ground and ground, applying friction force. So how are we able to walk? How do we walk? What we do is, when we are walking in the front direction, the ground is continuously applying friction force in the opposite direction, right? So the motion is towards the right, our motion, because the body is moving towards the right, and the friction that the ground is applying on our body is in the backward direction. That's why we are able to walk comfortably. Okay. Fine. So how can you define friction? You can define friction like this. You can say that friction is a resistance to the motion of one object which is moving relative to the another or relative to the other object. That is the definition of friction. You can also add that friction is an enemy to the motion and it always acts in the opposite direction to the motion. I hope everyone is very, very clear about motion because we have repeated it so many number of times here. Okay. So having understood friction, let us also understand what are the factors on which friction depends. Okay. So suppose, now let's take an example of, two boys who are trying to slide down. Okay. And one is trying to slide down over a surface which is much smoother than as compared to the other. So which is that surface which is much more smooth? It is the snow. So he's using sledge and he's trying to actually slide down, whereas the other boy, he is trying to just slide down on a normal grass surface. Okay, so which one of the two do you think will be able to slide down faster and will be able to come down faster? The boy who is sliding on the snow, he will be able to slide down faster. Now understand why. Okay, now here, which of the surface is smooth and which is rough? The snow is smooth and the grass is rough. Okay, so also understand that whenever the surface is rough, the friction force is greater. The friction force is more. Why? Because on a rough surface, there are a lot of obstruction. You won't be able to slip faster. So the friction force is more. However, on a smooth surface, the friction is less. Okay, this needs to be understood very carefully, very nicely. So on a rough surface, the friction is more. On a smooth surface, the friction is less. Okay. So friction is a kind of obstruction, I told you. So now tell me, if the friction is going to be more, is the movement or motion, will it be more or will it be less? If the friction will be more, if the obstruction will be more, if the huddles are more, then the movement of the object is going to be very less. Okay. But in the other case, on a smooth surface, here the friction was less. So that means the obstruction is less. You can understand, I'm telling you all these terms like obstruction, huddles and all these things so that you can relate friction to your normal day-to-day life. Friction is a kind of obstruction to any motion, right? So if the friction is less, then the motion will be more because the body will be able to move faster. So smoother the surface, lesser the friction, more the motion. Okay, rougher the surface, more the friction and lesser the motion. So friction and motion are inversely proportional to each other. Please write down somewhere, friction is inversely proportional to motion of the object. If the friction is more, the motion is going to be less. However, if the friction is less, then the motion of the object is going to be more. Okay, so nature of the surface determines the amount of friction that you are going to come across. Okay, if you are sliding over a smooth surface, you will be able to slide faster. Why? Because there is less friction, right? So the nature of the surface will determine the friction. Okay, so that is one thing. I have taken another example here. Suppose you're trying to push a box. Okay, and what you do is you just spill some oil. Okay, don't actually do it, but just try and imagine that you either spill some oil or some soap water on the floor, and then place this object here. Suppose this is on the left. Okay, the first object. So now try to push the object. Okay, and the other, let's say another surface is a rough surface, probably you can consider road, and you're trying to actually push the object on a rough road. So on which surface do you think that you will be able to push the object fast, quickly? Obviously on a smooth surface, because now again understand the reason. On a smooth surface, when the surface is smooth, what is the friction here? Because the surface is smooth, the friction is going to be less, because there is less obstruction. The floor is very smooth, and that's why the movement of the object is going to be very fast. Okay. However, on a rough road, how much ever you try and push the box, you have to apply, probably 10 of you will have to come together and push the same amount of load. So on a rough surface, the friction is going to be more, so the motion of the object is going to be less. Okay, so what is the gist? What is the summary here? The nature of the surface will decide what is going to be the friction. How much is going to be the friction? On a smooth surface, the friction is going to be very less. On a rough surface, the friction is going to be large, more. Okay. Now, another factor which will decide about the friction is your weight. So suppose you're trying to, there's a truck which is standing, okay, and there's the truck is, let's say, 50 kg truck, okay, and another small object is, let's say, 5 kg object. So which one of the object do you think you will be able to move quickly, move fast? Obviously, the 50 kg, the 5 kg box you'll be able to move it quickly, okay, as compared to the huge truck, okay, 50 or some 50 kg box which is kept. So the more the weight, now understand, the more the weight, if the weight is more, then the friction is also going to be more. Okay, and friction and motion are inversely proportional. So the motion of the object is going to be less here. Okay, I'm just writing, I'm just using some alphabets to tell you that this is weight. So understand that W is weight, F is friction, and M is motion. Okay, you are supposed to write it down properly, not like me. I'm just trying to explain to you. Okay, so if the weight of an object is very high, then the friction will also be large, and if the friction is large, then the motion of that object is going to be very less, and that's why 50 kg object will probably go only till this point. However, the other object which is just 5 kg in weight, okay, which is just 5 kgs in weight, what here the weight is less. If the weight is less, then the friction force is also going to be less. And if the friction is less, then the motion of the object is going to be very large, very high. So this object is probably going to travel a longer distance than as compared to the heavy object. Okay, so what are the factors which will decide the friction? First is your nature of the surface, and secondly your weight of the object. Okay, the weight will decide. So these are the two factors which will decide as to what is going to be your friction. Okay, so this we have done. So now tell me, suppose I give you a question. If you throw some soap water on your floor, why is that you slip easily? Okay, or suppose you apply soap on your hand, you are able to move your hand very easily against each other. Why is it so? You have to give me a reason, and talk in terms of physics. Okay, so what should be the reason? Because it's a soap water, so it makes the surface smooth. Okay, because it's a soap water, it makes the surface smooth. Because the surface has become smooth now, so the friction has become less, and when the friction becomes less, then the motion of the object will be more. So suppose if you're trying to walk on this type of surface where there is soap water, then there are high chances that your movement is going to be very fast. You will be moving very fast. So there are chances for of you to slip easily over the soap water, okay, or any kind of smooth surface. Fine. Now let's move ahead, and these are the points that we discussed in the last class. So smooth surface will have less friction, rough surface will have more friction, heavy object are going to have will offer more friction, and light object are going to offer less friction. So this is something that we need to understand. We need to keep that in our mind, okay, and then only proceed forward to understand friction. Now I'm sure you will have this doubt in your mind as to, okay, fine, we understand what is friction, we understand how friction is more and where friction is less, but then what exactly is friction, and where does this friction come from? Who causes the friction? What causes the friction? Okay, now look at this object here as shown in the slide here. Okay, this is the first this is the A is the first surface that I've shown here. This is the bottom surface, and there is another object which is B, which is trying to which is stationary or maybe moving. So this is the object. It can be a ball, it can be anything. So this is the second object. So these two objects are trying to slide or trying to move against each other. So where this is the object. Look at this. The green one below is one object, and the orange one, the light orange that is shown here, is the second object, right? So now these two objects are actually either sliding or they are moving against each other. Now when we see these two objects, we don't find any irregularities. Means we see that both the objects are very smooth with very, very smooth boundaries like this. So these are the boundaries, very smooth boundaries. But if I enlarge this image, then you will find that every object has got some irregularities. It's just that we don't see them, okay? But every object has irregularities, okay? That means it is uneven towards the edges like that. So this is the irregularities here. Both the objects, whether it is a smooth table or it is a rough surface. If it is a rough surface, then the irregularities will be more. Suppose if it is a rough road, okay, this is a road, it is a rough road, so the irregularities will be more in this case. But suppose if it is a smooth shining table, then the irregularities will be less, right? But every object will have some some irregularities in it. Now what is going to happen is these irregularities, they interlock into each other. So look at this interlocking. So look at this here. Are you able to see these irregularities? They're trying to actually fit into each other. So because of these irregularities, they fit into each other. That is something which causes friction, okay? Suppose, for example, the two objects would have been very smooth like this, okay? Very smooth like these two objects. So obviously, if the surface is smooth, there is no obstruction, so they will move very smoothly against each other. But that does not happen. That does not happen. What happens is there are always some irregularities in every object, whether you keep two books together, two notebooks together, or you're moving a ball on the ground, or you're moving anything. The ball also has certain irregularities. The ground also has certain irregularities. So because of these irregularities, there is always some kind of friction which will be offered by the two objects. And that's why this is the real reason for friction to be caused. That is why the friction is caused. Okay. Now, so what is the reason for the friction? The irregularities is the real cause for the friction, okay, between the two objects. Now let's study about these irregularities in little more detail so that you understand more about the irregularities now. So suppose initially this is the state, okay, this is the initial state. If the object is stationary, okay, suppose I have two notebooks kept on each other, or let's say I have a box which is kept on the floor, right? So the box also has certain irregularities. So if let's say if this is the box and this is the ground, this is the floor. So both of them has certain irregularities. But initially when they are at rest, so this is at rest position, okay, the first one is at rest position. So when the two objects are at rest and they are not moving against each other, okay, that means what is going to happen, both the irregularities on both the surface will interlock into each other perfectly. They are interlocked properly because they are getting more time for interlocking. Yes, someone is asking, is it compulsory that there is irregularities? Yes, Ayush, it is. There are always some irregularities. There are irregularities, okay? But in some objects, the irregularities are less. In the other objects, the irregularities are more, okay? The rougher the surface, the irregularities will be more, okay? And the smoother the surface, the irregularities are going to be less, fine? So, but there are irregularities. So, understand that when two objects are at rest, so that means the irregularities of both the surfaces will get more time to interlock because they're resting now. They're resting, okay? They have a lot of time to get interlocked between each other, right? So this is the rest position. The first position is the rest position here. But suppose if I apply a force, so what am I doing? My force is much more to unlock the irregularities. So suppose if I apply the force, so the object will start moving now. When the object will start moving, look at this, the second picture here. When the object will start moving, that means the irregularities will be shifted and they will no more be in the interlocked position. Why? Because I have applied more force. I have applied force which is much more stronger so as to unlock them, right? So these irregularities now will unlock, okay? So what will happen? The object now moves, okay? So that's why in which two case do you think the friction is going to be more? In which two case is the friction going to be more? Okay, the one in the first, in the rest position, that is called as static friction. Static means stationary. Whenever any object is at rest, it is called static. When any object is moving, it is dynamic now, right? So in the first position, this position is called as static. Okay, and here it is moving, maybe sliding, maybe rolling, whatever it is, but it is moving now. So in the first position, the friction is more. Write it down somewhere. It is very, very important for you to understand. Why is the friction more? Because the irregularities of both the surface have perfectly interlocked into each other. However, when I apply force to the object, then the object starts moving and the irregularities actually they do not lock into each other now, okay? They unlock. That's why the friction now becomes less, okay? If the friction is less, then only the object will be able to move, you know? If the agar friction zyada hoga, to object stationary hoga, right? So we have to overcome that friction. How do we overcome that friction? We overcome friction by applying force to it. Correct? Do you get me? So now understand these points. Smooth surface will have less irregularities. I told you that. Rough surface will have more irregularities. When the object is placed over another surface, the irregularities are locked into each other. Absolutely clear to you? Now, when we apply force, then the irregularities start to unlock and the object starts to move ahead. Okay? In this, I can ask you one more question. In which of the two picture that has been shown here, in which case is the irregularities, is the friction more? So where is the friction more? In the first case, that is when the object is at rest. Fine? So I hope you understand this. Why is this friction there and what is static friction? Okay? And how do we overcome friction? How do we overcome friction? By applying force to any object. Okay, now another one is, now you have to, there are some small little questions that we can ask you related to whatever we have learnt till now. When we rub our hands, in winters we generally keep rubbing our hands. Why do we rub our hands? Because we want to feel warm. We want our hands to be warm, right? So while rubbing the hands, why do our hands feel warm? what makes this heat get produced in between our hands? Now suppose you're rubbing your hand and your hands are now dry. Okay, yeah, the heavy things will have more irregularities. Yes, Ayush, it will have more irregularities, you're correct. Okay, so let's come to this. Okay, when you're rubbing your hand, okay, so suppose your hands are dry now. Okay, so if your hands are dry, and in the other case, let's say you have applied some oil in your hand, so in which case do you think that when you rub your hand it will feel more warm, more heat? In the first case, because your hands are dry, that's why when you rub them, because they are dry, they're rough, right? Because your hands are dry, your hands are rough. And I told you, when something is rough, there is going to be more friction between them. So when you rub your hands, there is more friction in between your hands, and that friction is going to produce some heat between your hands. Okay, but when you have oil, or let's say when you have applied soap, right? Yes, when you have applied soap, what happens? Both the surfaces are very smooth. So very smooth means less friction between your hands when you have applied soap or when you have applied oil between your hands. So the friction is very less. If the friction is less, then the movement is going to be more between your hands, and so much of heat is not produced by both your hands. Heat is only produced when there is more friction. I'll give you one more example. Okay, you all must be having bicycles at your place, or let's say mixer and grinder, or any machine. What happens when you use the machine for a long period of time? Let's say you're grinding something, so you're grinding for a longer time. What happens to the machine? The machine suddenly becomes hot. Why? Because all the parts of the parts of the machine are actually getting rubbed against each other, and that's why when they rub against each other, they produce heat. So one more point that you can write down and make a good note of it is that friction produces heat. Okay, friction produces heat here. Okay, friction produces heat. Fine. How does friction produce heat? I've just told you. Yes, heat. Absolutely right. So I can understand that you all are following me absolutely. Okay, let's now move ahead. Okay, another one is friction produces heat. Another example that I would like to give and present to all of you. How is that the friction produces heat? So you've must have seen this example, must have some or the other on some other occasion you must have lightened the matchstick. So what happens? Have you ever touched this portion of the matchstick? So it is slightly rough. It is not smooth. Suppose if this is a matchbox, then the top and the bottom surface of the matchbox, here and the bottom surface, it is very smooth. It has got some pictures or something like that, right? But on the two sides you have these designs here. Okay, so and the design that you see here, that is if you touch it with your hand, it is slightly rough. Obviously it has got some mixture also, which if you rub it against that match stick, it is going to light, it is going to give you fire. But then it is rough also. So why do they make it rough? So that the more rough it is, the more heat will be produced and you will be able to light that matchstick easily, right? Yeah. So that's the reason why matchstick, that surface catches fire very easily, because it is rough, and because it has that special kind of some mixture which is actually there inside that rough surface, which makes the candle light very easily. Okay. Now okay. Okay, Neetu is asking, friction is more on dry surface. Yes, it is. Friction is more on dry and rough surface, both. Yes, dry surface also and rough surface also. Friction will be more, and friction will be less on smooth surface and wet surfaces. Okay. Now, next is, this is also another example of friction, how it produces heat. I have already explained to you. So suppose you have all of you must be having your bicycles. So why do you oil your bicycles? You can just sometimes you may be hearing some unusual noise from your various parts of your cycle. So what you immediately do is you immediately oil your cycle, you grease your cycle, because if you do not grease, if you do not oil, these various parts of your cycle will keep rubbing against each other and it will produce heat, and at times it may break also, right? That's why you want to apply oil, because what will that oil do? The oil will make the surface smooth and reduce the friction. Okay, fine. This is, we're going to talk about it in next slides. Okay, so if I ask you, having studied so much about friction, okay, why only the matchstick catches fire and not other surfaces is because, see, I told you there are two reasons. One is that it is rough. Another thing I told there is some kind of extra powder that has been actually inserted in that rough surface. So because of that powder is the first thing basically. That powder only makes that fire to come up. Because if you rub two surfaces against each other, the matchstick also has got that brown color on the matchstick. That is also a kind of powder. Okay, and on the matchbox also, in that rough surface also there is a special powder which if you rub the two against each other, it will give rise to light. Okay, it will fire the matchstick. So that is the first reason. Second reason is you have to make it rough also. So there are two reasons. That's why the others, you rub two stones together, it will light fire, right? So that is the reason. Understood? Okay. Now next is what is the disadvantage of friction? Now, very important disadvantages of friction. You do want to make a note of these disadvantages and these points. The first is that we already discussed them. You can explain them in your own words. First is it produces heat. How does it produce heat? I've given you examples. You run your mixer and grinder, any kind of machine for a long time, it will produce heat, right? Second is wear and tear. How wear and tear? I've just explained you again. If you have your bicycles and you don't oil them, and the various parts of this, let's say the bicycles are actually rubbing against each other, after some time what will happen is you don't oil them, if you continue to use them in that condition, then some of the parts may just wear away. Okay, the wear and tear takes place if you don't use them properly. Okay, next is it reduces the efficiency of the machine. What do you mean by reducing the efficiency? Means the output from the machine that you're generally getting, you will not get that output. Okay, the machine will not work properly. Efficiency means the output that you're getting. So initially your grinder was working fine, your cycle was working fine, but now because of continuous more friction which is being produced between the parts, the cycle will stop working fine. Yes, then some noise also comes. That is also because the two parts are rubbing against each other, right? Now suppose, for example, if you oil your hands and you try to rub your hands, you will not hear so much of noise. But if your hands are rough and they are dry, and then you rub your hands, you will be able to hear slightly more voice or noise as compared to when your hands are smooth. So that's just an additional thing that comes out with heat, with wear and tear, with low efficiency. You have noise also coming. Okay, you have unwanted noise also coming. Yes, the unwanted noise is also a result of more friction being produced in any machine. Fine. Okay, if my voice is not clear, I will end it. Just wait for 2 minutes. I'll be back on the same channel. Just wait for 2 minutes.